Hello, everyone. Welcome back to this live series on data science with Python by PamTen. So, in this series, till now, we've learned all of the Python fundamentals, and then we've also learned how to do data manipulation and data visualization with Python. And since this is a live session, I shall be taking up any queries or any feedback that you have in the chat section. So you can go ahead and put your queries. So let me also check if the audio and video are working properly from my side. Data manipulation. Okay, seems like the audio and video are working properly. So on that note, we will go ahead and look at the agenda. In today's class, we'll be learning some basic fundamentals in statistics, and we'll also be implementing those principles with Python. So, statistics forms the backbone of data science and machine learning. So, if you are someone who's not really comfortable with stats and probability or calculus, well, this is the time that you have to brush up your stat skills so that you can be a proper data scientist. And in this particular class, we'll look at the very fundamentals. So we'll learn about measures of central tendency, measures of spread, and we'll also learn something called as the normal distribution. Now, imagine that you are in a class and there are a bunch of students. Obviously, you will have students in a class and you'd want to analyze the exam scores. So, how do you do that? Well, this is where statistics comes into picture. Now, you have two ways of analyzing these exam scores. So, the first way is to measure the central tendency, and the second way is to measure the spread. Now, what I mean by these two is, so when I talk about central tendency, I'd want to understand the average of the class performance. So, how is the performance of the class in general? And for this, we have three measures or three core principles of central tendency, which would be mean, median, and mode. And then we also have something called as measure of spread. Okay, we've understood how the class is performing in general, but I'd also want to understand how diverse are the marks when it is compared with the average class performance. So I'd want to understand if there are any outliers over here, or maybe if there are scores which are very far away from your mean, median, and mode. And this is where your measures of spread come in, and under measures of spread, we have something called as variance and standard deviation. Okay, so we understood the core fundamentals of descriptive statistics. And here in central tendency, we have our first method, which is mean. I'm pretty sure all of you would know what mean is. You would have worked on how to calculate an average of set of numbers, or how to calculate the mean of a set of numbers. So let me just go ahead and give a recap of this. Simply put, let's say if you have a bunch of data points, so let's say you have five students in a class, and these are the marks obtained by all of the students. And if you'd want to find out the average of all of the class, or average of all the scores, what you can do is you can sum up all the scores and then divide by the number of students. So you have five students and you have five scores. So what you do is you go ahead and add up all of the marks obtained by the students. So that becomes 90 plus 80 plus 85 plus 70 plus 95. So that is the sum of all of the marks obtained by the students. And once you get the sum, you can divide that by the number of students in the class. And since there are five students, you divide that with 5, and the average class performance seems to be 84. Now, here, there is one key point when it comes to mean, and that is mean is very sensitive to outliers. So, this would mean that if maybe, so on average, you will see that the score is around 84, but now instead of five students, if there were six students, and the sixth student had maybe, he did not study anything, he just came to the exam and gave an empty sheet to the professor. So, this person just got a zero on the exam. Now, because of this one student, the mean of the entire class will fall down. And this is what I mean when I say that mean is very sensitive to outliers. And I'll also give a very interesting example for this. So let's say you are at a function and or an event or a fundraiser, you can call it whatever you want, and the average salary of everyone in that event would be, let's say, $100,000 per annum. Now, it just happens that suddenly maybe Jeff Bezos or an Elon Musk walks into this event, and what happens is the average salary of everyone in this event shoots up. Initially, it was just $100,000, but since Elon Musk or Jeff Bezos has walked into the room, the average salary of everyone has shot up by a huge margin. So, this is what I mean when I say outlier. So, this is how we can work with a mean. Going ahead, we have another mode of central tendency, which is median. So, median is simply put the middle value in the data when we sort the data in ascending order. So, here again, we'll take all of these marks obtained by the students and we will arrange them in the ascending order. So, we get 70, 80, 85, 90, and 95. So, here you have 1, 2, 3, 4, and 5. So, you have odd number of values, so here you can just take in the middle value out of this. So here the third value would be your median, which is 85. And if there are even number of values, so here you have 70, 80, 85, and 90. From this, if you'd want to find out the median, what you can do is you can take out the middle two values and find their average. So here the median value would be, here the middle two values are 80 and 85. So you'll take up 80 and 85, add them up, divide by 2. So 80 plus 85 by 2 will give you the median in this case, which would be 82.5. Now, median is something which is not sensitive to outliers because you are sort of discarding the extreme values, or you are not taking up the extreme values. Now, when it comes to median, you are only focusing on the center value. So, that is why you can say that a median is a more robust measure or it is not sensitive to outliers. Going ahead, we have the final type of central tendency measure, which is a mode. And simply put, mode is just the most occurring value in a data set. Now, let's say in the previous example, if out of all the students, if most students had scored an average of around 75, right? So maybe you have a class of 100 students, and out of those 100 students, if maybe 40 or 45 students had scored maybe around 70, then that would become your mode, right? So basically, the value which occurs the most number of times, that becomes the mode of your data. In this case, you have these numbers 1, 2, 2, 3, and 4, and from these, the mode will be 2. Similarly, here you have 1, 2, 2, 3, 3, and 4. Here, what you have is you have two values which are occurring the most number of times. So that is why you can say that there are two modes for this data, or you can also call this bimodal. So 2 is the mode and also 3 is the mode, and that is why this is bimodal. And normally this is used for categorical values because you can actually count them properly. If this was actually a lot of numerical values or decimal values, then it would become quite difficult for you to find the mode, right? So let's say if it was maybe weight of a lot of people or height of a lot of people. So if I were to maybe look at the height of the entire population of the United States, then I wouldn't really be using mode because it will become very hard for me to look at the decimal points. Similarly, if I were to look at the weight of all the people in the United States, I wouldn't be using mode because, again, since there are decimal values, I cannot exactly pinpoint that this is the mode of the population. So these were some of the measures of central tendency. Now we'll see how can we implement these with Python. So we have two important libraries over here. We have something called as a NumPy, with which we can perform different types of numerical computation. And then we have also something called as SciPy, with which we can do scientific computation. And we give NumPy an alias of NP, and we give, so here, SciPy, we just import another submodule, and the name of that submodule is stats, and we have a bunch of data points over here. So this is, we just create a list and then we pass in a bunch of data points. Now, NumPy module gives us these two methods by default. So when we use np.mean and pass in this list inside this, this will automatically give us the mean value of this data set. Similarly, if I were to find out the median, so I'll say np.median, I will pass in the list and then I will get the median. Now, the mode is not present in the NumPy library. So that is why I shall be using the stats submodule from the SciPy library. I'll say stats.mode. I will pass in this list and this shall give me the result. So let's go to Google Colab and perform this operation. I have opened up Google Colab over here. Let me import the required libraries. I'll type import NumPy as NP, and I would also need the stats submodule from the SciPy module. So from SciPy import stats, I have imported these two. And in the meanwhile, if you have any questions, you can put them up in the chat section. I shall take them up. So while these two libraries are being loaded, let's just go ahead and write or create a list. So data, let me give in some random values over here. 6, 1, 9, 12, 53, 2. Okay, so we have our data ready. Now, if I want to find out the mean of this, I can just type np.mean. I will pass in the list that I've just created into this. And let's see what would be the result. So here for these bunch of numbers, we see that the mean value would be 12.428. Similarly, I can find out the median for this. So I'll type np dot median and I shall pass in data. And we see that the mean value is 6. So let's actually arrange this properly and see if this is correct or not. So we shall arrange all of these values in ascending order. Let me copy this. So we should have the sort method. Let's see if this works on top of this. Seems like we cannot print this. I'll cut this. I'll paste this. Okay. Or I can just go ahead and store this in a new variable. While is this, I shall go ahead and print out while. We don't really get anything. Sorted. Seems like this also does not exist. So what we can do is we can just go ahead and try to list down all of the values. So I have 2, 1, 2, 3, 6, 9, 12, and 54. So I have 1, 2, 3, 4, 5, 6, 7. So fourth value should be our median, which is 6. And that is what we get over here. So this is how our np.mean and np.median work. Now that we have understood these two, let's go ahead and also look at the mode. For this, I would need the stats submodule. So I'll say stats.mode. I shall pass in the data. Here, everything occurs only once. So maybe I'll try to increment the count of something. So I'll increment the number of ones which are present in this data set. And here you shall see that the mode is 1 and 1 occurs 3 times. Let me try to change this. So I shall have 54 and let me hit enter. Let me run this again and you shall see that mode is 54 and this value occurs 5 times. So this is how we can work with the measures of central tendency in Python. Going ahead, we have the measures of dispersion. So we've understood how to find out the average performance of something or the average value from a set of data points. Now I'd want to understand how are the data points actually spread out from this mean value or from this average value, and this is where variance comes in. So this is the formula for variation and variance, and I'll tell you how to calculate this. So this x of I is basically each data point, and from each data point, you'll be subtracting the mean value. So here for these list of scores of students, the mean is 84. And what I'll do is I'll subtract the mean value from each score obtained. So I'll say 70 minus 84, 80 minus 84, 85 minus 84, and so on. and then I will square up these values and sum them up. So 70 minus 84 whole square. Similarly, 80 minus 84 whole square, 85 minus 84 whole square, and I shall sum up those and I shall divide that with the number of scores, which is n. So here you have scores of 5 students. So I shall divide this by 5. And this is how we will get variance. Now that we've got the variance out of this, here you have to keep something in mind that the variance or the units of variance is different from the units of the actual data from which this variance was calculated. Because here you are squaring the values. So let's say if this was actually height of the students or maybe height of something or weight of something. Okay, so let's say this is weight of students in kilograms. Now, if you were to actually find out the variance, since you are calculating the square of this, what happens is so the kg will become kg square. Similarly, if these values were in meters, the variance will become meter square, right? So that is why when you are using variance, the units change and it wouldn't be so easy to interpret what it actually means. And this is where we have something called as a standard deviation. So when it comes to standard deviation, we just take the square root or under root of variance, and this basically represents the average distance of all the data points from the mean. So here, let's say if you have a variance of 50, and if you take the under root of this, you shall get the standard deviation to be 7.07. And here, these are some key features of standard deviation. So here, since standard deviation, since you're taking the square root of variance, the units of standard deviation shall be the same as that of the data. And also, if you have low standard deviation, this would mean that the data points are very close to the mean. This means that these are not spread out, right? So let's say if maybe the average of the class is around 50, then most of the data points or most of the values will be closer to 50. Similarly, if there is a high standard deviation, this would mean that data points are very spread out. Again, the same example. So let's say if the average score is 50, then this would mean that the actual data points are very spread out. So you'll have a lot of values which would be 60, 90, 12, and so on. And this is how we can understand the measures of dispersion. Going ahead, we'll see how to implement them in Python. Again, we shall create a list, and this time the NumPy library gives us two more methods. So we have the VAR method through which we can calculate the variance of the data, and I shall also have the standard STD method through which we can calculate the standard deviation. Let me go back to Google Colab over here, and this time let me print out data again. And what I'll do is I can, instead of this, maybe I shall create a new set of values. I'll have 10, 20, 30, 40, and 50. Let me again calculate the mean of this and let's see what do we get. So we get 30 to be the mean of this. Now I'd want to understand the standard deviation of this and variance of this. So here I'll have np dot variance of data, and we get the variance to be 200. And well, we can't really interpret much from this. Instead of this, what I'll do is I'll have np dot sd, and inside this I'll pass in data. This should be std, and we see that the standard deviation is around 14. Well, the actual, so since the mean is 30, this would mean that the values, they deviate by around 14 points towards 30. So on the left side of 30 and on the right side of 30. So this is how we can interpret the variance and standard deviation values in Python. Let's see what else do we have. Going ahead, we also have normal distribution. Now, let's say if we have heights of all of the students, and if I was trying to maybe understand how this is actually spread out. So till now we've looked at measures of central tendency and measures of deviation. Now, if I would actually want to make some sort of prediction or some sort of variation on this students heights data set, what I can do is I can create a normal distribution. So let's say I have found out the mean and standard deviation already for the heights of all of the students. And it comes out that the mean height of all the students is around 66 and the standard deviation is around 3 inches. Now, what this would mean is around 68% of the data lies within one standard deviation of the mean. Okay, that's too much jargon. What does it actually mean? This would mean that, so when I say one standard deviation, your mean is 66. So plus minus one standard deviation of 66. So the range would basically go from 63 to 69. So most of the height of the students, so 68% of the students in the class, their height will be between 63 and 69. And if you take two standard deviations, so this would be minus 6. So 66 minus 6 would be 60. 66 plus 6 would be 72. So between 60 and 72, right? So around 95% of the students will have their height between 60 and 72. And if you take three standard deviations, so you can basically subtract 9 from 66 and add 9 to 66, and you can say that 99.7% of the values lie within here. And also, this normal distribution sort of gives this bell curve, and you can clearly see that most of the data it lies somewhere over here, right? Most of the students, their average height would be around 60. And also, when you go to the left end or to the right end, there are very few students whose height would be greater than 75, or there would be very few students whose height would be less than 55. Now, let's go to Google Colab and let's see how can we create this beautiful normal distribution graph in Python. Let me just add a comment over here. I'll type in normal distribution and I shall import the required libraries. So I shall need matplotlib. I'll type from matplotlib import pyplot as plt. And also from the stats, what I would need is I would, well, let's also import stats for now. So I'll just type from scipy import stats, and the stats submodule shall provide us something called as norm, through which we can create a normal distribution. So I have these two ready for now. Now I can go ahead and so what I'll do is I can create a set of values. So for this, I'll set the mean to be equal to 66. So this is the mean height. I'm just setting this value in a variable. Similarly, I should have the variance. So I'll call the standard deviation and I'll set this to be 3. I have the mean and standard deviation ready. And after this, what I can do is I'll create a data set, or I'll create a list of 1,000 values which will start maybe four standard deviations on the left side of the mean and four standard deviations on the right side of the mean. So here I'll just type, so it shall start from mean minus of 4 into standard deviation and mean plus of 4 into standard deviation, and I would need 1,000 values. So for these 1,000 values, what is basically happening is the first value will have mean minus 4 times of standard deviation, and the 1,000th value or the last value will have 4. So mean plus of 4 into standard deviation, and I'll have a bunch of values over here. Let me just hit enter and I'll show you the values. So here you shall see that the values they basically start over here at 54 and they go till 78. So I have 1,000 values which start from 54 and go till 78. Now I've created all of this. I shall go ahead and store this in a new variable and call that to be X. Okay, I have a bunch of all of these heights. Now what I want to do is I can go ahead and create a normal distribution on top of this, and I shall store that in the Y variable. For here I have the stats submodule, so I shall say stats dot norm. Okay, so I'll actually import that. So I'll say import from stats import norm. Okay, Let's see if this actually works. Stats dot norm, and what I'd want is maybe norm dot pdf. Okay, this works. So the stats submodule has a function called as norm, and that has a PDF, which is basically your probability distribution function. And we are creating a probability distribution function over here. Now this, it takes in your x values, and those x values, I will again go ahead and what would I want to do? I shall go ahead and set the mean over here as your central location, and I shall scale it with respect to the standard deviation. So I'll set the scale to be equal to standard deviation. Let's hit enter, and I have a normal distribution created. I shall store this in a y variable. So this normal distribution I've basically created from this value. Now I shall go ahead and create the graph. I'll type in plt dot plot. I will pass in the x value onto the x-axis and the y value onto the y-axis, and I'll have plt dot show, and let's see how does this actually look like. Let's see if we get the desired normal distribution. Yes, we do get the normal distribution, and we see that most of the values over here are somewhere in the 64 to 66 range. And also, one important feature about normal distribution is this is where all of your mean, median, and mode will be same. So if you know that your data is normally distributed, you can for sure say that the mean, median, and mode are same, and they'll be present at the bell point or the top of the bell curve. So we've created this. Let's actually add a legend and the labels for x-axis and y-axis. Sure, I'll just type in label, and let me say, what do I need over here? I would need, I would have to set up the mean and standard deviation. So I'll have mean. Mean, I have stored it in a variable called as this. And I shall have over here, and I would also need something called as standard deviation, and the value of standard deviation is coming from std_dev. Let's hit enter. We would need to add the legend, so I'll say plt dot legend. We should get the legend now. So here you shall see that mean is 66 and standard deviation is 3. I can also go ahead and add a grid for this. So I'll type plt dot grid. Let's see if we can get a fancy grid now. Yes, we do have a fancy grid, and this looks much better. Now going ahead, I can add the x-axis and y-axis labels and also a title for this. So I'll say plt dot title normal distribution for height. I'll have plt dot x label, and here I shall set height, and I'll have plt dot y label, and here I'll just type in PDF, which is the probability distribution function. And yes, we have successfully created this graph. So friends, this was it for today's session. So we've learned about the measures of central tendency, measures of deviation, and then we also understood how can we interpret the information through a normal distribution curve. So these are the core fundamentals of statistics. And in the coming sessions, we'll be deep diving into some of your data science algorithms. So we'll be looking at classification algorithms and regression algorithms. So do join in for our next sessions as well. And if you've liked this video, do hit the like button, share it with your friends, and subscribe to our channel. Thank you very much.